Imagine a Mars with abundant liquid water, rivers, streams, and shorelines. It's a Mars we don't see today, but it's the Mars that once was. This isn't the stuff of science fiction, but a reality of the distant past. The geological features of Mars bear silent testament to a time when water flowed freely on its surface. This ancient Mars was a world quite different from the one we know today. It was a world warmed by a thick blanket of greenhouse gases, with an atmosphere likely composed mostly of carbon dioxide. Picture the sun, dimmer by 30% than it is today, its rays filtering through this dense atmosphere to warm Mars's surface. Evidence of this watery past is etched into the Martian landscape. The Mars of old was crisscrossed by rivers and streams that shaped its terrain over eons. The remnants of these rivers and their deltas, now dry and desolate, tell a tale of a planet that was once teeming with liquid water. This water didn't just flow on Mars's surface, but it also shaped its shorelines. Yes, Mars once had shorelines, the boundaries between land and ancient seas or oceans. These shorelines, though now devoid of the waves that once lapped against them, provide further evidence of Mars's watery past. But the big question is, what happened? How did this water-rich, lush Mars turn into the arid, barren landscape we see today? It's a mystery that scientists have been trying to unravel, and the answers they're finding are as fascinating as they are complex. Stay tuned as we delve deeper into this intriguing Martian mystery. Mars didn't lose its water overnight. It was a gradual process, primarily driven by the stripping of its atmosphere. Let's take a moment to appreciate the magnitude of this transformation. It's akin to watching a vibrant, bustling city turn into a ghost town, but on a planetary scale. So what exactly led to Mars losing its atmosphere? There were two main culprits: stripping by the solar wind and diffusion into the subsurface. Now, these might sound like complicated processes, but don't worry, we're about to break them down. First up, stripping by the solar wind. Imagine the solar wind as a gusty breeze, but instead of blowing leaves off trees, it's blowing away Mars's atmosphere. The sun, our friendly neighborhood star, is constantly emitting streams of charged particles known as the solar wind. This solar wind interacts with the Martian atmosphere, gradually stripping it away over billions of years. Next, we have diffusion into the subsurface. This is a bit like when you spill coffee on a tablecloth. The liquid doesn't just stay on the surface, it seeps into the fabric. Similarly, Mars's atmosphere didn't just stay up in the sky. Over time, it diffused into the subsurface, disappearing from the air above. Now you might be wondering, how do we know all this? Enter MAVEN. This spacecraft, whose name stands for Mars Atmosphere and Volatile Evolution, has been studying the stripping of the Martian atmosphere since 2014. MAVEN's estimates suggest that more than 25 meters of global equivalent layer, or GEL, of water may have been lost to space. That's like losing an Olympic-sized swimming pool's worth of water every second for billions of years. Mars had lost more than just water and air, it had lost its life-sustaining elements. Just like that bustling city that turned into a ghost town, Mars had lost its potential for life as we know it. But fear not, the story doesn't end here. As we delve deeper into Mars's past, we're also securing its future. We're unlocking the secrets of a planet, and who knows what we might find next. The loss of Mars' atmosphere also meant the loss of crucial elements: hydrogen, oxygen, and carbon. Now, these aren't just random elements on the periodic table. They are the building blocks of water and carbon dioxide, making them vital for the potential of life as we know it. So how exactly did Mars lose these elements? It's a tale of celestial winds and atomic diffusion. The first culprit is the solar wind, a stream of charged particles ejected from the sun's atmosphere. This wind can strip away the Martian atmosphere, carrying away hydrogen and oxygen atoms into the vast expanse of space. The second process is diffusion into the Martian subsurface. This is where these atoms simply seep into the ground, getting lost in the planetary crust. This process is slower, but no less effective in its steady erosion of the atmosphere. The loss of these elements isn't constant, though. It changes with the Martian seasons. The loss of hydrogen, for instance, increases near perihelion, when Mars is closest to the sun. The higher temperatures and atmospheric dust during this period make it easier for hydrogen atoms to escape the atmosphere. Oxygen, on the other hand, is lost through various processes. Ionization, where an atom or molecule acquires a negative or positive charge, can cause oxygen atoms to be carried away by the solar wind. Photochemical reactions triggered by sunlight can also lead to the loss of oxygen. The loss of carbon is a bit trickier to track. You see, carbon is tied up in carbon dioxide, and estimates suggest that Mars may have lost 1 to 2 bars of carbon dioxide over time. That's a significant chunk of the atmosphere gone. The loss of these elements marked a turning point in Mars's history from a potentially habitable planet to a barren, inhospitable one. Today, the water on Mars is a mere shadow of its past. The once abundant liquid water that carved rivers and streams on the Martian surface has dwindled to a fraction of its former glory. Where did all that water go? Well, it's primarily locked up in the polar caps and in mid- and high-latitude ground ice. This is the water that remains after billions of years of loss to space and diffusion into the subsurface. But the story of water on Mars doesn't end there. There's more to this tale than meets the eye. You see, Mars may be hiding water in places we can't immediately see. There's a possibility that water is bound in hydrated minerals on the Martian surface. These minerals, formed long ago when water was plentiful, may still hold water molecules within their crystal structures today. And let's not forget about the hidden water beneath the Martian surface. While it's hard to pin down the exact amount, scientists believe that there could be significant quantities of water hidden beneath the surface. This water could be in the form of ice, or it could be trapped in underground reservoirs. This hidden water is of particular interest to scientists, as it could hold clues to Mars's past and possibly its future. So even though Mars may appear as a dry, barren world from afar, it's not entirely devoid of water. Yes, the water is not as accessible or abundant as it once was, but it's still there. And each droplet, each ice crystal, each water molecule holds a piece of the puzzle that is Mars's past. It's like a time capsule waiting to be unlocked. And who knows, perhaps one day we might be able to tap into these resources to support human exploration and possibly colonization of the red planet. Mars may appear dry, but it still holds traces of its watery past. Understanding Mars's past is crucial to securing its future. The more we know about Mars, the better equipped we are to plan for potential future explorations or even colonization. As we've seen, Mars was once a planet rich with liquid water and a thick atmosphere, conditions that could have potentially supported life. However, over time it lost these crucial elements through stripping by the solar wind, diffusion into the subsurface, and other complex processes. Today, Mars is a cold, barren planet, with water primarily locked up in polar caps and hidden beneath the surface. As we continue to study Mars, we aim to learn more about these processes and to uncover more about the planet's history. This knowledge is not only fascinating in its own right, but it may also help us to anticipate and plan for the challenges of future Mars exploration and potential colonization. As we unlock more secrets of Mars's past, we step closer to a future where Mars could once again hold potential for life. Don't forget to like, subscribe, and share your thoughts on Mars's past and its future in the comments below.